sigma notation is a very important topic whereby if you misunderstand it, you lose quite many marks. So as we do this topic, please ask as many questions as you can. Okay, all right, so here we go. Now, sigma notation, like I said, what we do here, we are going to write the terms, okay? So I was saying that writing out the terms of a series can be tedious and time consuming. So what we do, we introduce what? The sigma notation, okay? Which is quicker and easier to write down. So we use the Greek letter. This letter is called sigma to indicate the sum of the series. So like you see, this one means summation. Like we're going to add T1 plus T2 plus T3 and so on until the last term, which is Tn, okay? So if we talk about delta like this notation we read as the sum of Tk from K of Tk for K from 1 to n. I repeat, you see, the moment you see something like this, okay, in your test or anywhere, and we say from K equals to 1, okay, up to n, all together, then you put here Tk, all together. How do we read it? The sum of what? The sum of Tk for K from 1 to n. Can you read it for me? The sum of what?
The sum of Tk from K from of A. The sum of Tk from K.
It is for K.
For each
Say it again.
A. Okay. It's the sum of Tk for K from 1 to n.
Now let me explain what you see. You see this Tk, this K means that we must be having an expression here containing K. Like this, for example, can talk about summation, okay? I can say let me say 3K, okay? Then minus 1. All together. Then we say from K equals to 1 up to, let's say, up to 7. All together. So now what we do here, we keep on starting with the K equals to 1. So this one, if we proceed, it's gonna be something like this, okay? It's gonna be something like we put it. We're gonna say 3, okay? I'm write it here. We're gonna say 3 all together. What is our K? Our K is 1. Starting from 1, then I say minus 1 all together. That's my first term now. So to get my next term, I'm gonna put what now? I'm gonna put 2. My K is what? I'm gonna say 3 times 2 all together. Then I say minus 1, okay, all together. Then I continue like this. I'm gonna say now what? What do you think I'm gonna say? 3, okay, into what? Into 3 all together. Then minus 1. What about my next term? What am I gonna do now? I'm gonna say what? I'm gonna say 3 into what? Into 4 all together. Then minus what? Minus 1 all together.
1.
Until I got the last term. Now my last term here, it must end at 7, okay? So what am I gonna write now? I'm gonna say 3 times what? 3 times 7, okay, minus 1. So basically, what you see here is what is described in all this notation here. So this notation, it means exactly what you see from here up to here. That's what we mean. So are we together now?
Yes, sir.
Okay, so let us proceed with the examples, okay, to make it more understandable. Now, what you see as TK, this TK we call it the general term. It could be for arithmetic series, or could be for geometric series. Let us proceed now here. So applying the sigma notation, okay. So here a series written in sigma notation takes the following form. So we begin from the first K, the first value, until the last value, all together. Then we have the expression in terms of K. Now what I'm going to emphasize here, if the beginning variable here is K, it must be in the expression, nothing else. You don't have to have a different variable in here. Okay. But however, you can use B, you can use any letter, but it must be in the expression here, to avoid confusion. Okay, to avoid what? Confusion. So You're saying that any variable may be used, not necessarily, okay? So the series represented by this notation can be found by assigning consecutive integer values to the variable, starting with the number below the sigma notation, which is called the first value, and ending with the number above the sigma notation, the last value. Ne? So each of these integer values is substituted into the expression, and each result obtained represents what? A term of the series. So to calculate the value of the sum represented by the sigma, we just add all the terms together. We just add. We just what? We just add all the terms together so as to calculate the value of the sum. Okay? We're going to see examples just shortly, but I hope we are together for now. Are we together for now?
Yeah.
Can I proceed?
Yes, sir.
Are you coughing or is your neighbor coughing? Okay, now here I have the sum of 2k from k equals to 1 up to 5. Did you hear that? I said what? The sum of 2k from k equals to 1 up to 5. Ne? So what's my first value here? I put in 1. All together. After
Yes.
that, now I'm going to say plus. Then I put what? I put a 2. All together. Then I say plus, I put a 3. I say plus, I put a 4. Plus, I put a 5 until I get my answer here. So when I add all these ones together, I get
So,
my
sir,
30. Yes. You have a question?
the case is it just like saying t is equals to 1, then term 2,
Yes,
term 3, term 4?
yes. This K helps us to get the terms. Ne? Like when I put in 1, this is T1. This one is our term T2.
Mm-hmm.
This is our term T3. Okay. This is our
Yeah.
term T4. Our term T5. All together. So in order to get our T1, it is 2 times 1, which is 2. To get our T2, 2 times 2 is what? It is 4. Ne? Then to get our
Yes,
T3,
sir.
we said 2 times 3 gives us what? 6. What about to get our T4? 2 times 4 gives us what? 8. What about to get our T5? 2 times 5 gives us what? 10. So when you add all these terms, you get the set, which is the sum. Are we together? Okay. Now
Yes, sir.
sometimes can it be like this one, which is now geometric, like in this case with the power. Again, don't mess up. The first term here is what you must substitute first. Ne? Like you see here, our k is from 3 up to 7. Okay. What am I going to put here? I said 2 to the power 3 all together. Then I said minus 1 all together to get our T1. Okay. Then I'm going to, what comes after 3? We go to 4. So now we put a 4 here to get our next term all together. Then we put a 5 to get the next term. Then put a 6 next term. They said you must stop at 7. So we stop at 7 here all together. So when simplify here and get your answer and the answer and the answer, then you can add, you get 124 all together. Okay, are we together?
Yes, sir.
Sometimes they can use I, like the sum of I squared from I equals to 3 up to 4. So our first I is what? Is 3. That's why there's a 3 here.
3.
What comes after 3? It's 4. Then we
4.
stop there, which gives us 20 what? 25. Are we together? So, but
Yes, sir.
however, not something that if there is no variable in here and just a constant, ne? Hello, I repeat. If there is no like R, no T, no K, no X, no I, nothing here, ne? But only the constant, ne? Then they say from R equals to 1 up to 20, it means we are gonna add that constant 20 times. I repeat. If we don't have any variable to put in here, ne? Like I or R altogether, ne? You're gonna do what? You're gonna count, or we are gonna sum, we are gonna add this constant. How many times? From 1 up to 20. That means 20 times. In other words, you can say 3 times 20. For that, we're gonna say 3 plus 3 plus 3. How many times? 20 times, which makes it 20 times. Are we together now?
Yes, sir.
So do you have any questions so far?
Nah,
Can I proceed? Okay, let's proceed now. Before look at some.
I don't have any question.
Come again. We can proceed, ne? Okay.
Yeah, I don't have any questions.
So I can proceed, ne? Okay, no problem. Now you must know how to find the what? Okay, we have some questions here. It is important to note that the sum of tk from k equals 1 up to n, we call it Sn. Now this Sn is the same as the sum of all the tk values up to what? Up to n. So we can calculate the sum of the series written in sigma notation by first expanding the series and then using the appropriate sum formula. So I repeat here, you know what we do when they give us a question all together, we first expand the series all together. After expanding the series, then we use the appropriate formula. Now this formula can be the one for the geometric or arithmetic. We have got two types, ne? All together. And then when we are done, we find the sum of those
Yes,
n
sir.
terms, ne? Okay. But however, yeah, I think we are fine for now. Can I do some questions here? If you check what we have here, we have example 22 here. It says what? Read for me. Evaluate what?
We evaluate the following.
The summation of 2k minus 6 from k equals to 1 up to 10. Eh? Are we together? Let us do it together here and you see what I'm talking about. Okay. Let us do it together
Sir,
here. Do you have a question or we are
sir,
together? Hello? Yes.
I have a question. Can you sum up a few numbers, then if it's at arithmetic, then we use the Tn to find the number of terms. I mean, yeah.
Yes, yes.
Okay.
To find the sum of terms, the sum of the terms, not number of terms.
Oh, we're looking for sum.
Yeah, this one means sum.
Then,
Yeah.
then we can use the sum formula for
Yes,
arithmetic
yes,
patterns.
that's correct. The sum formula for the arithmetic. Then Wabona here it is
Oh,
geometric, ne? Then here we use the sum formula for the geometric. Even here
sir,
geometric, that's what we have. Please, you have a question?
no, you were cutting. I couldn't hear you.
Okay, I was saying that we have to identify whether it is geometric or arithmetic, ne? So whenever it is linear like
Mm,
this, it is actually arithmetic. Are we together? If it has got powers, it is geometric. Are we together? Then we are going to know the common
mm,
ratio or the common difference. Then we're going to know the first term. Are we together? And also to know the number of terms. Then we can find. Then we can find the what? We can find the sum of those terms using
the
the sum
sum.
formula, which could be either geometric
Mm,
or arithmetic. So can you choose any
oh,
two from here which we can do as examples for you? Which one can we do here? Should we do B and C or
can
we
we
do A
do
and
number
C or A and B?
A and B? Look, I did A.
You
I,
did B.
I
Good.
found number A.
Okay. What's your answer?
The difference was 2.
Answer was 2, ne?
Yeah, the difference.
Oh, the common difference was 2. Okay. Let us find it out. Let us go slowly. Let us find out here
Mm,
the procedure. So now we are going to find now first of all our number of terms here, they're gonna be 10. How do you get 10? By saying 10 minus 1 plus 1, which gives us 10 times, ne? So we're going to find out our T1, okay, then our T2, okay, then our T3, okay, and so on until the last time, which is going to be T10, okay. Are we together? So how to get our T1 here? We said we substitute, ne? I'm going to put K equals to 1, ne?
mm,
It's going to be 2 into 1 minus 1, 1 minus 6, all together. That will be my T1, all together. Then plus 2, okay, into now 2, all together, minus 6, are we together? That's going to be our T2. Then plus, open brackets, 2, okay. Now, by the way, we always write only the first 3 times, ne? because we just want to identify the common difference and then to see what we need. Okay, so and then we're gonna say and so on. What's gonna be our last term here? I'm gonna put k equals to 10. Is that fine with you? 2 into 10, then minus what? Minus 6. Now, what is 2 times 1?
2 times what?
It is 2, ne? What is 2 minus 6?
Minus 4.
Negative. That's our T1, ne? Let's come here now. What is 2 times 2?
4.
4 minus 6?
Negative 2.
That's our second term now, okay? Let's come here now. What is 2 times 3?
6.
6 minus 6?
0.
0, okay? Then we come until the last term now. What is 2 times 10?
2 times 10, 20.
20 minus 6?
14.
We get 14. So now if you check what I have here, what is minus 2 minus minus 4? Or what is 0 minus
2.
minus 2? We see we get 2, ne? Now that 2 is our common difference, ne? Because if you say minus 2 minus minus 4, we see it gives us what? It gives us 2. Even if you say 0 minus minus 2, it gives us 2, ne? Okay, so from here, what about our first term? What's our first term here? Negative what? Negative 4, ne?
4.
What about our last term?
Yeah.
Last term is what?
14.
It is 14, okay. So we're going to use which formula here? We're going to use what?
Sum formula.
I mean,
Of
is it
arithmetic.
for arithmetic or geometric? It is for arithmetic, ne?
It's for arithmetic,
So
yeah.
how would we state it? It is n over 2, okay, open brackets,
Yeah.
okay, and 2a plus
And
what?
2a
Plus
plus
n minus
n
1,
minus 1
then times d.
times difference.
Are we together? So let us now we're talking about 10 terms, ne? So to get our sum of the first 10 terms, we're gonna say 10 divided by what? 10 divided by 2, okay? Then 2a, what is our
Times
a?
negative 4.
Our a was negative 4,
Negative 4.
okay? Then plus, what's 10 minus 1? You get 9, okay?
9.
What about common difference was what? It was 2,
2.
okay? So here, what is 2 times minus 4? What is 10 divided by 2? You get 5, ne? Right? What is 2 times minus 4? Minus 8, ne? What is 9 times 2? What do we get?
18.
18,
18.
okay. And what's 18 minus 8?
10.
10 times 5?
25. Yeah? 50. 50.
So the answer
50.
is 50. Did you get it right?
Yeah.
You got it right, ne?
Yeah, I got it
Yeah,
right.
that's how we do it. Thank you for that. So, what about for the geometry? Can I do for one for the geometric here, or you're fine with them?
I'm fine with it. Let's do C.
We do C, ne? Okay. Let us work out this here and see what happens. So, can I clean up this one here? All.
Yeah, we can.
I send you on the group on your chat the screenshot. Do you need it?
No, I wrote it. Can I go fetch my charger? I'll come back.
No problem. You can go do that. You can go do that. I'll wait for you, ne? Yeah, don't forget you are trying out C, ne? I'm telling when you are done, okay? Yeah, I'm waiting for you, ne? Now, if you check what we have here, this one means sum to infinity, ne? So we're going to substitute now, okay? We're going to do what? We're going to substitute now and see what happens. So we're going to say our term T1, okay? T1 plus what? Plus T2, okay? Plus T3, okay? And so on, okay? Because it goes up to infinity, ne? So how do you get our first term here? we're going to put in I equals to 5, né? As you see it here, I equals to
Yes,
5 up to infinity. So we are going to say, we're going to write open bracket 3, okay, all together, then power 6 minus 1. What's our first I? It is 5, né? So 6 minus 5, okay. Then plus, next time here, we're going to say again bracket 3, power what? Power 6 minus what now? 6 minus 6, ne? Then actually we need only 3, ne? Again plus
Yes,
3, okay. To the power what? 6 minus what?
7.
6 minus 7, okay. Then we say plus so many until infinity, ne? So from here, what is 6 minus 1? 6 minus 5, sorry.
1.
Then 3 power 1 is going to be 3, ne? All together. What about 6 minus 6?
6, 0.
So what's 3 power 0?
1.
1. Okay, what about 6 minus 7?
Negative 1.
Then 3 power negative 1, you cannot use what? 1 over 3, ne?
1 over 3.
So from here, can you tell me what do you think is our common ratio here?
1 over 3.
1 over 3. What about our first term?
3.
That is 3, okay. So what does the formula say for the sum to infinity? It says what?
There's something, it's A over 1 minus R.
Yeah, S infinity equals to A over 1 minus R. Okay, so from here, what is our A?
3.
Our A is 3, ne? 3 divided by, what about our common ratio?
1 over 3.
1 over 3, okay, that's correct. So from here now, can I have the final answer, please?
9 over 2.
9 over 2, ne? Which is the same as 4 comma what? 4 comma 5, ne?
4.5.
Did you get it right?
Yes, sir.
Wow, that's good, that's good. Okay. So I think we are fine with this now, don't you think so?
I think so.
So should we stop here?
Yeah, we can start.
Okay, no problem. So now I have some questions for you here. You can try them in your free time, okay? So when we meet again, we'll be marking them, okay? Please try all the questions, ne? Don't give up, ne? Try all of them,
Okay.
and then as soon as you're done, I can mark them. Then we take it from there, okay? All right. Bye bye.
Okay.
Bye. See you next
Bye.
time.